Hello everyone, hope you guys are doing great and having a great vacation. On this video I'm gonna be talking about our test exam that we had lately. I have both versions of the exam, the questions, I combined them together, so we're gonna go one by one. So this is about the chemical properties. Now, in the first question, it is asking which of the following does not go under polymerization. If you guys remember, we talked about polymerization in my other video, which I highly recommend to rewatch before your midterm. For polymerization, you need to always have a double bond, meaning one sigma and one pi bond, such as we have in alkenes. Okay. So out of here, you can see that we have double bonds in in C, B, and D options, but not in A. So A is going to be the one that does not go polymerization. And if you remember, we have talked about the other polymers. So this is in the B version, the question that we have, which of the following is polypropylene? It is in our PowerPoint. If you go there, so polypropylene is, other name is polypropene. Polypropene is made from monomer propene. So this is a polymer name and this is a monomer. We know that the propene, you need to have 3 carbons, and then propene means that it is alkene, so you need to have a double bond, so like this. And if you know that, if you remember our valency on carbon, we know that we have 4 bonds on each carbon, so I'm gonna fill it up to 4 bonds. So now that we have propene monomer, so this is propene or propylene, the other name, which is also given in our PowerPoints. And now we're gonna do polymerization of this guy, and when you polymerize it, you break this double bond, and this is how it looks like. So double bonds breaks down, and this CH3 is just I'm gonna write it as like this CH3. And okay, so we broke the double bond, and now I can make this polymer. I can connect to another monomer from here and to another monomer from here, and this is how it's gonna look like. And if you check all these answers, not this, neither this nor this, and this is the only answer for polypropylene. So actually, if I would write all of them, they would be looking like this. So I just bring this 2 H's closer and I write here, and then I'm gonna bring this one closer to CH, and I will bring CH3 here. This is the condensed version. So this is how it looks like. So n amount. You see, like it is connecting to another monomer like this, and just it continues on, and from same thing from this side. Okay, so now in the question 2, hydrogenation reaction. So a lot of you had a mistake with hydrogenation and hydration. Hydrogenation is addition of hydrogen. Hydration is addition of water. You guys made a lot of mistakes on this. So hydrogenation reaction can be used in food industry to convert liquid oils to other solid alternatives. If you remember, we had some liquid oils where you would have add hydrogen, and you would get a product of solid oil. And this hydrogenation happens like this. So let's say you had a double bond somewhere. So this, let's say this is a part of the oil. You see this double bond here, and then you add two hydrogens in here. And the way it happens, you see the carbon that is in the middle. It has one hydrogen on it, because we know that each carbon will have 4 bonds. So I got 1, 2, 3, 4 bonds, right? So when we do it, we break this double bond when I add the hydrogen. And now the way it looks is that now I have 2 carbons. So for this branches, I don't care at this point. The only thing I care is this carbons and their bonds. So I had these 2 hydrogens before. But now since I broke this bond, I have a chance to add 2 hydrogens, which I will add into here. So as you see, now it's looking like this. And I showed you this was a liquid version of the oil, and this is the solid oil. If you check out our PowerPoint and the video, you would see this. Now, in the B version of the exam, we had indicate the statement below as a true or false. So this one was true, and for this one, it says polymers are divided into natural polymers such as PET bottles, PE films, PP granules, and synthetic polymers such as silk, wool, and cotton. It is actually wrong. So synthetic ones are the ones PET, PE films, and PP granules, and natural ones are silk, wool, and cotton. So this is why it was false. And then now we continue. In the A version, it says select the correct catalyst for hydration. Hydration, again, adding of the water for the alkenes. And in hydration, if you remember, let's say we had carbon, and let's say we had hydrogen and hydrogen like this. And when you would add the water, you would have an acidic condition of H2SO4, and you would break the double bond. Then hydrogens are here, and one of the hydrogens from the water goes here, and the OH that is left is going to go here. And this is dehydration. And it's going to be B. So for the B version, we had select the correct region for the Bayer test. So for Bayer test, if you remember, it was we used potassium permanganate. We would add on alkene. For example, if we had alkene, we add potassium permanganate, and then we add the water. The product would be ethylene glycol, which is the antifreeze. And you would have OH here, and you would have OH here. And this is going to be MnO2 and potassium hydroxide. This is the full reaction. So that is that. Now the question 4, which of the following below given alcohols is tertiary alcohol? If you remember, and check my videos, you would see that alcohol that are primary would have OH group attached to carbon with either 2 or more hydrogens. Carbons with just 1 hydrogen would be secondary, and the tertiary carbons would have only 1 hydrogen attached. No hydrogen attached, sorry. No hydrogen attached. So if you check this one, so you see this carbon, you have 2 hydrogens. So this is primary. If you check out this carbon which is attached to OH, you have one hydrogen, so this is secondary. And if you check out this OH, this attached to two hydrogens, the carbon with two hydrogens, so this is primary. And then this carbon which is attached to OH has no hydrogen, so this is tertiary. That's why the answer is C. Okay, and then for the B version, we were asking for the secondary one, and the secondary for B version, the answer was this, if it was asking for the secondary. Tertiary is this guy. Okay, so now choose the correct options regarding the chemical properties of organic compounds. So if you would check our first slide, we had over there saying that saturated, we had alkanes, and we had alkenes. For alkanes, we only have sigma bonds, and for alkenes, we have sigma and the pi bonds. We said that saturated hydrocarbons undergo substitution reactions due to the presence of sigma bonds between carbon atoms. Because alkenes itself is a saturated, it only goes into substitution. For example, let's say we had ethane. We know that we won't be able to add anything in here. It's all sigma bonds. The only thing we can do is substitute, and then what we do, we would add, let's say, a chlorine in here, and then your substitution would be looking like this. So H, and then for C, H, and then you would have a chlorine here, and then this would be the byproduct. For example, this is the substitution. That's why the right answer is here. And then we know that the alkenes, since they have a double bond, or alkynes, they are unsaturated. And we can have addition reactions on them. For example, if I had ethene, like in here, I can add hydrogen on it, right? And I would break the pi bond, and this is the way it will look. I will add hydrogen just like this, and this is addition. So addition is for unsaturated ones. Unsaturated hydrocarbons undergo addition reactions due to the presence of pi bonds, and this is the answer is 3. Most of you got this right, some people didn't, so you can check out the PowerPoint again, and it will clear it out for you. So, question 6. Combustion is the burning of compound in the presence of oxygen. Most of you got this right, so there was no problem. If the color of the flame is blue, then the complete combustion process takes. If the color of the flame is orange or red or yellow, either of the answers, it's fine. Then it is incomplete combustion process. Incomplete combustion happens due to low amount of oxygen gas. And for the B version, we changed it for complete, and in that case it was high amount of gas, and that was it. Because if you would check the reactions, the reason we call this high and low amounts is due to this. For example, if I had C2H6 and I would do combustion of that, it is CO2 and then water. This is complete, right? So let's do the balancing. So it would be 2 carbons and then 3 hydrogens, and then it would be 4, 7. 4 plus 3 is 7, so this would be 2 over 7. And then if I multiply everything by 2, it's going to give me 2, 7, 4, and 6. But for incomplete, it's going to be 2 CH2 6 and then O2. It gives us CO and a water. So I got 2 carbons here, 3 hydrogens there, and then this would be 2 over 5. And if I multiply everything by 2, you would see 2, 5, 4, and 6. Now in this case, if you compare the number of oxygens, you would see that for complete, you have 7 moles of oxygen, and for incomplete, you have 5 moles. So you could see that from here, this is high amount, and this is low amount of oxygen. Now question 7. We did change it for the B version, so I'm going to show it in the next one. So choose the correct statements. It says unsaturated hydrocarbons decolorize the potassium permanganate solution. Even in our lab, if you guys remember, because inside we had a purple solution, and I put the pipe inside of the solution, and it became turned from purple into either colorless or orange or like light orange color. So it did change, and it happened due to unsaturated hydrocarbons. I showed you the reaction up here. So this one we have. So this reaction, potassium permanganate, this is a purple color solution. And this product that we have, this one is a colorless ethylene glycol. The reason we had this reaction turning from purple to colorless is due to the double bond we had over here. If we had, let's say, alkane over there and it was saturated, it would not decolorize. So that's why the first answer is right. Potassium permanganate is a salt with orange color. That is wrong. It is a purple color. If you check it, the PowerPoint, you would see it. Ethylene glycol is one of the products of oxidation of ethine. It was not ethine, it was ethene. That's why this answer is wrong too. And ethylene glycol is a colorless, viscous, hygroscopic liquid as an antifreeze, used as an antifreeze. And if you would check the slides, you would see that 1 and 4 were the answers. Now, we changed for the B version, it says saturated hydrocarbons decolorize. It is wrong because it is gotta be unsaturated for it to be correct. Potassium permanganate is a solution is a salt with a purple color. That is correct in this case. Ethylene glycol is one of the products of oxidation of ethene. That's why this is correct. And ethylene glycol is a colorless, viscous, hygroscopic liquid used as detergent. That is incorrect. That's why the answers would be, like in this case, it was 1, 2, 3, and 4, and the answer were 2 and 3. So now we're going to go into question with balancing. It was asking to complete the combustion reaction, complete combustion. So complete combustion is CO2 and a water, and then CO2 and a water. If you would just write this, you would get a 1 point. And now we're going to do the balancing. So we have here 5, and then I got here 6. 10 plus 6, 18. 10 plus 6 is 16, minus 1, 15, and this would be 15 over 2, and then you would multiply everything by 2, so your numbers would be 2 and 15, and over here 10 and 12. Those were the numbers. And then for the second question, you had 6 carbons, and then you had 3 of the water. So now you need to check the number of oxygens. So 12 plus 3, is 15, and this would be 15 over 2 again, and then you would multiply everything by 2, which will give you 2, 15, 12, and 6. Now we're going to do it for the B version. So now it's asking us to write the incomplete combustion. You would write CO and water, and then CO and water, and just writing this will get you 1 point, and then you start balancing 6 and 7. Now you got 6 plus 7, 13 minus 1, so this would give you 6, and everything is fine right now. And then you would do 5 in here, 6 in here, and then you would check out the oxygens, which is 5 plus 6, 11. So this would give you 11 over 2, and then you will multiply everything by 2, and this would be 2, 11, 10, and 12. And these are your numbers. Okay, so now the next question. Finish the following reaction and name the products according to IUPAC rule. We know that this is a bromination reaction. Bromination reaction. So when you write this guy, CH3, CH, you would be breaking down the double bond because this is an addition reaction. And you would add this bromine into this carbon, and voila, this is your product. And then you would start numbering the carbons in order to name. We always start numbering from the closest to the branch, and then we have bromine and bromine. That's why I will be numbering from here: 1, 2, 3, 4, and 5. So this would be 2, 3, D bromo, pentane, because I got 5 carbons on the main chain. And then once you check out this one, we're gonna just write this guy without the double bond in order to write the product. So I would just write it like this. I'm just gonna write in expanded form so you would guys see it. So you guys would see it. And then CH2, then I got CH, and then this branch of methyl, and then another methyl. And then I'm gonna just add the hydrogens. I just add the hydrogen in here. As you see, it transformed into another alkane. Now it's all saturated, and we're gonna number carbons. We'll number always from the closest to the branch, which is this guy. The main chain is this. I got carbon 1, 2, 3, 4, and 5. So the root is pentane. And because on the second carbon I have a methyl group, it would be 2-methyl pentane. And that is the answer. This was the same thing for the B version, almost the same. So now, next question is, it is asking us to deduce, meaning write the balanced equation for the incomplete combustion of pentane 1 molecule. Calculate the mass amount of water molecule produced from 5 moles of pentane's incomplete combustion. Now guys, we have done it many times, and I'm just gonna do it. So this is the A version, this is the B version of the test. We have done it in the class, so if you haven't been able to write it, to be honest, that means you didn't really practice. So let's write this one together. So pentane, we know that it is alkyne. Mechanical alkynes generic formula is this: CnH2n-2, and pentane, you know, it is 5, so it would be C5. H would be 2 times 5 minus 2, and this will give you C5H8. And now it's asking you to write incomplete combustion for that. meaning C5H8 plus oxygen, you would get CO and H2O. And then you got 5 carbons here and 4 of the water here. You would check the oxygens. Now I got 5 in here, 4 there, 9, and this would be 9/2, and then you would multiply everything by 2, and which will give you 2 here. And then if I delete this, it's gonna be 9 here, and then it would be 10 for here, and then 8 for this guy, 8 for here. So now that we have everything set up with our balancing, if you would write this, you would get 1 point from here. Now it's asking 5 moles of pentyne 1's incomplete combustion. So we know that these coefficients are giving us the numbers, number of the moles. So if you have 2 mole of C5H8, you would get 8 mole of water. Okay, so for 5 mole of pentyne, you would get X mole, and we do the ratio. So 2 times X would be 8 times 5, and this would be X is 20 moles of water. And you know that the formula N equals to M over MM, which is the molar mass of water. You can find the molar mass of water from the periodic table. Hydrogen is 1, so you got 2 hydrogens, 2 times 1 plus oxygen is 16, and then this would be 18 gram per mole. And you have the number of moles, you have the molar mass, you can find the mass of the water, which would be 20 mole multiplied by 18 gram per mole. And mole cancels out, it would be 360 grams. You can use this formula or you can do proportions, it's up to you. You can write like this with proportions. For 1 mole, it is 18 gram for water, and 20 mole would be X gram, and X would be 360 gram. So this is the second version of the solution, and this was the first version. It's up to you. Okay, so, and you can do it for the B version, heptine, it would be C7H2 times 7 minus 2, and this would be C7H12. So you can do and practice for yourself the same exact thing with the different coefficients. And now the next question. Butene 1 is a colorless gas that is easily condensed to give a colorless liquid. So this is general information. Polymerization of butene 1 gives polybutene, which is used to make piping for domestic plumbing. Write down a full chemical equation, include all needed conditions of butene 1, hydration, and name products X according to IUPAC rule. So over here, we need to write down first of all what is butene 1, and then we need to write the hydration, meaning addition of water, not the hydrogen, just water. And then we're going to name the product. So butene 1, if I would write the expanded form, you got 4 carbons, and then on the first carbon you have a double bond. This is the skeleton, and then we keep filling with hydrogens till we have 4 bonds on each carbon. Okay, this is your expanded form, and then you would add the water in here. Water is written as HOH, and then H2SO4 is your catalyst for this reaction. So we used it in our lab too. So I'm just gonna write it like this, and let's get going. So the first thing you would do, you would break this bond, and then you would break the bond in here. And then we know that reach gets richer, meaning the one which has more hydrogen gets even more hydrogens. So richness is in this case, the quantity is hydrogen. So let's check out this carbons. This carbon has 2 hydrogens, while this carbon has 1 hydrogen. So this one is apparently rich, right? So he's the one who's going to get another hydrogen. So once I write it, I'm just going to go like this. And for this side, I don't need to write them in expanded form. I can just write CH2 and CH3, right? And I can bring down this 2 hydrogens closer to this. Let's not bring it. Let's not confuse you. I'm just going to write it as it is. And now, once we broke this down, this one portion has H, the other portion has OH. So rich gets richer. This guy gets the hydrogen. The other one gets the OH. Okay, so now we made an alcohol. If you write the condensed form, this is going to be looking like this. So CH3, CH, OH, and then CH2 and CH3. And when we do the naming, we find the longest chain, which is this, and we start naming closest to the OH for naming of the alcohol, because OH is for alcohols. And then 1, 2, 3, and 4. So you got in here butan, and it's going to be on a second carbon you have OH, so butanol. And this is the name for your alcohol. And then we're going to go into this is your product X, guys, X. So product X formed in part 1 undergoes oxidation reaction. Write down the full oxidation reaction and name the products. So again, we're going to write our product here, CH3, CH. I'm just going to write this part in expanded form, CH3, and then we're going to go oxidation reaction. So now we know that this carbon is secondary because secondary alcohol. The reason is because the carbon that is attached to OH has 1 hydrogen directly attached to him. And when we do oxidation, what we need to do is we're going to get rid of these 2 hydrogens. So let's write this guy without those 2 hydrogens, CO like this, and CH2 and CH3. And then in order to compensate for this and complete the carbon valency to 4, meaning 4 bonds, we're just going to put a bond like this. I'll put it with green so you would see it. And this is your product. And this is, in this case, is ketone. And in order to name this, again, we start numbering from the closest to O double bond. 1, 2, 3, 4. So because I got 4 carbons, it would be again butan. It's going to be 2 on, and this is ending for ketone. And this is the name for this guy. And then question part 3. Product X and ethanoic acid undergoes esterification reaction. Write the full esterification reaction. So again, I'm writing the product X here, CH3 and CHOH, and then I got CH2 and CH3, and then on top of it I add ethanoic acid. Ethanoic acid, I need to have 2 carbons. So I write down 2 carbons. I know the ending of carboxylic acid is OH, and the rest of the stuff I fill it with hydrogens. Let's write it in expanded form. There you go. And then now we're going to make the esterification reaction. Again, we make sulfuric acid to create acidic environment. So now, in this case, we're gonna grab OH from here, and then H from this guy. And OH and H, they would make us a water. There we go. And then let's write this, whatever we're left with. So I'm gonna write ethanoic acid part. So that, and then you see I have a carbon with a double bond oxygen. And this alcohol, as you see, I'm gonna write it like this. So oxygen combines here, and then I've got CH, CH3, and then CH2 and CH3. I just did it like this, and this is my final product. I can even write this guy, this part of the carbon in condensed form. So I'm just gonna remove this parts, and I can write it like this, CH3. And I can even give you guys a line diagram of this. So I got 1, 2 carbons here, and then 1, 2, 3 carbons, right? So 2 carbons, and then I do like this, and then 1 like this. So 1, 2 carbons, 1, 2, 3 carbons, and another carbon up here. This is my line diagram, the final version. Okay, so now we move on to the next question. Now, vinyl chloride monomer or chloroethene is a colorless compound. So we have this in our PPT. So chloroethene or vinyl chloride is written as like this. I got 2 carbons, I've got 1 chlorine, hydrogen, 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 and then I would have a double bond like this. Now, it is asking us to write down the full polymerization reaction for vinyl chloride. Okay, now for the B version, we were asking for propene. So I'm going to write both of them. So propene is, I have written it above, is CH2, CH, and then CH3. This is the propene. So let's do the vinyl first, vinyl chloride. So I've got CH, chloride, CH, and then like this. So I'm gonna do high temperature pressure. We don't need to really write the condition. It wasn't asked. So I'm just gonna break the double bond. I will write my chlorine, hydrogen, 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 and then I would put this in a bracket, and then I would just attach from both sides another monomer. So this is a monomer, and now I made a polymer with the N number, which is not given to us yet. And the name of this polymer is gonna be polyvinyl chloride. Okay, and now I will do propene, which is actually I have written above. So CH2, I got CH, and then CH3. So I'm gonna pass it through polymerization. I will break the double bond, carbon, carbon, and then I would write this like this without the double bonds. And I'm gonna put it inside the bracket, and I will attach from both sides. And this is the polypropene, or the other name is polypropylene. So we actually gave you a hint in this part of exam to an answer for the first part, the first question. And now it's asking us to calculate the degree of polymerization for vinyl chloride. So let's find the molar mass of the monomer. Molar mass of, what do we have here? 2 carbons, C2. How many hydrogens? 3 hydrogens. and then chlorine. This is the everything we have inside the monomer. So you got 2 carbons. Carbon is 12. So 12 times 2 plus 3 times 1 plus 35.5. And this would be 24 plus 3, 27, so 62.5. And then if you would pay attention, you would see the molar mass of polymer is 375. So we had this equation m equals to m over times n. N is the degree of polymerization. Degree is, you see this n number in meaning how many ends we have attached, how many of these monomers they are attached to each other, that they add up to this guy, right? So if I have one of the monomer is 62.5 grams, and then if how many I need to have in order to get 375,000 grams, and this would be 62.5 grams multiplied by n, and n you would get this number 375,000 divided by 62.5, it would be 6,000, which is your degree of polymerization. And now for this one we just did it the other way around. For polypropylene, let's write, so you know that it is made from propene. We don't even need to look up there, CnH2n. So C3, it would be H6. So molar mass of C3H6 would be 3 times 12 plus 6 times 1, and this would be 42 grams. And then you would do the same formula, 42 grams multiplied by n amount, which is given to you, degree of polymerization, 12,000, and whatever the number is, you would plug it in there. And it is 504,000 grams, which is 504 kilograms. Okay. And now we move on to the question 13. It gives us the primary alcohol, secondary and tertiary alcohols with 2, 3, and 4 carbons. Okay, so we know that if we have 2 carbons and if we have a primary alcohol, it would be looking like this, right? And then if you would fill it with hydrogens, you would clearly see that this is ethanol, this primary carbon. And secondary alcohol is given with 3 carbons. So I'm going to write like this, and then OH. If you would fill out with hydrogens, this would be looking like this, right? This is your secondary alcohol. Now for tertiary alcohol, you need to have carbon with no hydrogens, meaning you would take everything from carbon and then OH, and then you would fill out with hydrogens, and this is your tertiary alcohol. Now the products of this, guys, so if you see we have a difference in here, O2, O, and O. This O2 refers to combustion. We didn't exactly give you whether this is complete or incomplete, so if you would have written here CO2 or CO and a water, we would give you full point. But even in this case, because it's not fully specified, because this could be addition of like oxidation too, if you have written here an aldehyde, like this, or CH3 and COOH, or carboxylic acid, which is the next stage of the oxidation, you would get the full point. Okay? And for secondary alcohol, you know that once you oxidize this, you're going to lose these 2 hydrogens. Secondary alcohol always give ketone as a product. So this is how it's looking like. And then tertiary alcohol, there would be no reaction. Now it's asking us name the secondary and tertiary alcohols. So because I said tertiary alcohol, we're not asked for the product yet. We're asked for the names, and we're gonna be looking at this tertiary alcohol first. So you see this is the longest chain of carbons, right? So you start numbering 1, 2, 3. It doesn't matter from top to bottom or bottom to top. It's the same thing. So because you have 3 carbons on the main chain, so it's going to be something with propane, propan root, and then it would be 2 methyl, propan, 2 ol, because on a second carbon you have the OH. That is the name for the tertiary, and for the secondary, let's check it out. So you got, this is the longest chain we have, and then I'm gonna number 1, 2, 3. It doesn't matter wherever you go, from left to right or right to left. So this would be propan 2 ol, because on the second carbon you have the OH, and this is methyl to propan 2 ol. Okay, so now write the complete chemical equations for the formation of products A and C. So you see, like, we have 1, 2, 3, and 4 versions of the products because it wasn't specified. Either way, we will give you full points if you would write one of them, and if you will write their names. So you could see this one's name is ethanol because it is aldehyde. This is ethanoic acid, and this one is carbon dioxide and water. The other one is carbon monoxide and water. So either of the name would work for A. And for C, you see that write the complete chemical equations. You see there was no reaction, so we would write down that there would be no reaction. That's why no name for the products. Okay, so before I go, I'm just gonna name this one too for ketone. So I got 3 carbons, so I'm gonna start numbering 1, 2, 3. It's the same thing, left to right, right to left. So I've got propan, because it is ketone, it would be propan 2 on, because on a second carbon you have a double bonded oxygen. Propan 2 on. Now, how does the structure of alcohol affect its reactivity during oxidation? So you could write a lot of stuff in here, like in words in different versions. The main thing is that for primary alcohol, in oxidation, they give out aldehyde. And if you go one more step for oxidation, you would get carboxylic acid. Secondary alcohol would give ketone. And then tertiary alcohol, no reaction. And that's it. If you summarize this in words, that is just fine. So now this is the B version of the test. I'm just going to write you down so you would see what we have. So I got primary alcohol with 3 carbons. So meaning I have to have 3 carbons like this. And I would put the OH in the end because I know that the carbon that is attached to OH need to have 2 hydrogens. So I'm going to fill out the rest with hydrogens. So this is would called propan 1 ol or propanol, doesn't matter. Okay, and secondary alcohol with 4 carbons, you need to have carbon, carbon, carbon. And then in one of them you would put OH. So you can put carbon like this. So whatever you put, either you're going to put it on this carbon or this carbon. And either way, if you will turn them around, they are the same thing. So we're just going to fill it with hydrogens to fill up to 4 valency. And now the name of this is going to be butan 2 ol, because on the second carbon you have the OH group. And then tertiary alcohol with 5 carbons, you know that this carbon needs to have 4 bonds like this. So you can put carbon here, or here, it doesn't matter, it's going to be the same thing. So CH3, CH2, and CH3. And the name of this guy with 5 carbons, it would be methyl butan 2 ol 1, 2, 3, and 4 when you number the carbons. Okay, and this is the methyl group that you have up top. So now it's asking us to write down the name of this secondary and tertiary. So you would I just already did. So secondary, this is secondary butan 2-ol. And then tertiary is 2-methyl butan 2-ol. So, and this is the tertiary one. And now write the complete chemical equation for formation of products A and B and name the products. So in this case, you see we gave you actually oxidation specifically. So for this one, you would give us CH3, CH2, and COH, which is propanol. That is the name of the A product. And we're asking for the B. So in this case, you're going to convert the secondary alcohol to ketone. And this would be CH3, C, double bond oxygen, CH2, and CH3. And this would be butan 2-ol. And this is your product. Once you number it, you would see why I have written it like this. Because it is ketone, the ending would be on. And then for C, you know that there would be no reaction. The same thing with the A version. How does the structure of alcohols affect its reactivity during oxidation? I have written it above. It's the same thing for this version too. Now question 14. During the laboratory, students was provided 2 chemical compounds labeled X and Y. The teacher has given a student some information regarding the chemicals in the beakers. Compound X and Y has different molecular formula. Compound X has a general formula of CnH2n, which means that it is alkene. And then it is the 4th member of its organic family, and compound Y is the 3rd member of its organic family, has a general formula like this. And then boiling point of Y is more than X, and then bromine is used as a chemical test to identify compound X, and compound X reacts with water producing tertiary alcohol. These are the important information. So we know that compound X has a general formula of CnH2n. We know the first member of alkene is gonna be ethene, because there is no such thing as methane being like CH2. There is no such thing. So ethene, so you're going to start with 2 carbons. This is your first member. Second member is going to have 3 carbons. Third member will have 4 carbons. And the 4th member will have 5 carbons. This is your carbon amount. So it would be C5H10. Okay? This is your compound X empirical formula. And then you have the alcohol with OH is the 3rd member. We know that the first member is going to be methanol, CH3OH. This is methanol. And then it's going to be, the second member is ethanol, C2H5OH. If you put in the number, so carbon amount is 1, and then 2. And then if you plug it in 3 in here, it would be C3H7OH, and this would be propanol. This is ethanol. So this is our compound Y. And this is our compound X. So now, let's answer the questions below. Explain why compound Y has a higher boiling point than X. So this is our previous term question. We know that the compound Y is alcohol, Alcohols have hydrogen bonding, which is why they have higher boiling point. This is basically that. If you mention any of these words, it is fine. We know that alkenes, they have other intermolecular forces such as van der Waals, but because hydrogen bonding is stronger than van der Waals, so that's why it's going to be compound Y will have higher boiling point than X. Now the second portion is that write the full chemical reaction for Bayer test that is performed on compound X. So for compound X, we know that it is making tertiary alcohol. Let's approximately write the shape of this with water. So if I have carbon, 5 carbons, and if I make a tertiary alcohol, I need to be looking somewhere like this. So tertiary alcohol, so if I would be looking like this, I can make a tertiary alcohol, because if I do the hydration in here, we know that we have CH3, and then CH and CH3. We know that if I do hydration on this, rich gets richer. I know that this guy is rich. So I'm gonna add hydrogen in there, and I would be making CH3, COH, CH3, CH2, and CH3. As you see, I made tertiary alcohol in here. Okay, so but this is not asking us that. I just wanted to find out how it's looking like, our alkene. It is asking us to write the chemical reaction for Bayer test. So Bayer test means that I would be adding potassium permanganate and water, and look at the product we have. I've got CH3, C, CH3, CH, and then I got OH here, and then CH3, and then the product would be mangano 2 and potassium hydroxide. These are my products. Okay. Now in the third one, it's asking write the chemical reaction of bromination of compound X and name the organic product. Now let's write the bromination reaction. Once I do bromination, I'm just going to add broma. I'm going to break the double bond. I just broke the double bond, and I will add the bromine here, and then bromine here. And name the organic product. Let's name it. So I will start numbering from here because the branches are closer to the left side. So it would be 2, 3, D-bromo, and then 2-methyl butane. Okay, and then that is the name, and explain why brom 2 is used as a chemical test. So if you would write here for unsaturation check, because we know that we have here alkene which is unsaturated, while the propanol C3H7OH, for example, if I would run CH3, CH2, and OH, you see it is saturated. In order to differentiate between them, I would run the bromination test. And I know that the product X will turn the bromine to colorless. This will turn bromine, this is a colorless product. While if I'll add alcohol and then bromine to it, it will not change the color, So it will give us a negative result. Okay. And then it is asking us calculate the moles of organic compound found in part 3 for 40 grams of bromine used. So you know that if I would write just a condensed form of this, or just a molecular formula of what do we have here, C5H10, and I would add bromine to it, the product is C5H10 and brom2, right? So everything is 1 molar ratio. It is telling you if I would add 40 grams of bromine, which, as you see, bromine here is shown as brom2. So molar mass of brom2 would be 80 multiplied by 2, which is 160 grams. And then if you would check the number, so let's say, what do we have here? So 1 mole is 160 grams, and then 40 grams would be x moles. So from here you would see that x is gonna be 160x would be 40, and x would be 0.25 mole. So bromine is 0.25 mole, and this is because it is 1-to-1 ratio, this would be 0.25 mole as well. So that is the answer for the found in part 2, meaning for the x amount we're taking. And then it is asking us write the balanced chemical reaction for hydration of compound X, which I actually have written it above, but I'm gonna still write it again here. So I've got here CH3, and then CH3, and then I would have here CH3 like this. I would add the water. I told you rich gets richer, and this guy is the one who is rich with hydrogen compared to this one. So the product would be CH3, COH, CH3, CH2, and CH3. And the name of this guy is gonna be, so I got the longest chain is this, so I'll start naming. So 1, 2, 3, 4, so it would be 2-methyl butan 2-ol. And that's it, guys. That is it for the question. It's the B version. It's pretty much the same thing. We didn't really change much in here. So I will see you guys in the other video. Thank you.